Okay, the first problem we got is the f of x is equal to the square root, or x minus 9 over the square root of x. Now, before I start this problem, I just want to make sure you understand that there's different ways that you could do these problems. One is you can just go through and do the quotient rule. The second way you can do it is go through and do the inverse rule of exponents. I'm going to put E-I-R, inverse rule of exponents, exponential inverse rule. Then do the product rule. The other thing you could do is do the inverse rule, the exponential inverse rule, and just do the power rule, or a little bit of algebra, sorry, and then do the power rule of derivatives. Now, my main point in telling you these three methods is because I don't want you to think that with derivatives and doing the basic rules of derivatives that there is one set rule of doing things. There isn't. Let's take, for example, the quotient rule. If I was to bring this up, first of all, I'd change it to a rational exponent. Bring that upstairs, it's going to be x minus 9 to x to the negative 1/2 power if I wanted to use the product rule. So right now we're going to use this. That's for the quotient rule. So the quotient rule says, first, I'm going to denominator. I'm going to do the quotient rule. Denominator times numerator prime. Well, the numerator is x minus 9, so the derivative of x minus 9 is 1, minus brackets x minus 9 times the derivative of x to the 1/2, which would be 1/2 x to the negative 1/2, using your basic power rule. All that over x to the 1/2 squared, which is x to the 1/2 squared. I'm going to just put it here, but you know that x to the 1/2 squared, the 2 will cancel the 1/2 out, and you're left with x. Also, since I got my marker out, this is important. Why is this important? Because of this guy right here. That guy right there will cause all kind of trouble. So that's why I put brackets out in front. Okay? Everybody with me so far? Let me get another marker here. So, this comes out to be x to the 1/2 minus brackets. I'm going to go ahead and clean this up. This is x minus 9 over 1, so I'm going to make it go with this 1 and bring this 2 to the negative 1/2 down with this 2. And that's going to be x minus 9 over 2x to the 1/2, all over x. Now, I've got some more cleaning up to do. I've got to make this a common denominator. I've got all kinds of things to do. All this is algebra. We're done with the calculus. The algebra is going to be kind of hairy. It's complex rational expression. So, first thing I'm going to do, put this over 1. So we got to have a common denominator, which is 2x to the 1/2. So I got to multiply this times 2x to the 1/2. So I'm going to get 2x to the 1/2 times x to the 1/2 minus, parentheses, x minus 9, all that over 2x to the 1/2, and all that over x. I'll make this fraction bar a little bit bigger, x over 1. put this right here and I'll move it over so, because we're going to take it right over here. Now, you can, when you divide by a fraction, you multiply by the what? By the reciprocal, so you can move that x right here. And that 1 times all of that's not going to change, and down here is going to be times x, which is to the 2 halves, so that'll be 3 halves. So we've got 2x, because x to the 1 half times x to the 1 half is x to the 2 halves, which is x to the 1, minus x plus 9 over 2x to the 3 halves. Now, before you get crazy and before you start saying, I don't know how you did that, well, 1 times all of this is that. Distribute that negative. Distribute that negative. You're going to get negative x plus 9. I'm looking for a marker. These markers, they kind of get kind of dull real quick. So I'm going to get a marker right quick. I don't try to get a black one. Sorry. Holding up the paper. So I distribute this negative with this negative, this x and this negative 9, and that becomes negative x plus 9, and then 2x minus x is x plus 9 over 2x to the 3 halves. That's your answer. So here we use the quotient rule, and when we use the quotient rule, hold on 1 second, I'm trying to move it to where you can see everything. That's your answer. Alright, now that's when we use the quotient rule. Now let's use the inverse rule of exponents and move the inverse rule of exponents. Let's move it up, the denominator up to the top, and see what happens. So that's going to be f of x is equal to x minus 9 times x to the negative 1/2 power. Now we use the product rule. Product rule says first times the derivative of the second, so x minus 9 times the derivative of the second, which would be negative 1/2 x to the negative 3 halves, plus the second times the derivative of the first, and the derivative of x is 1. So now we've kind of got what we had a while ago. F prime of x is equal to, I'm going to bring that x minus 9 with this 1, so negative x minus 9 over 2x to the 3 halves plus 1 over x to the 1/2. Now, of course, we've got to have a common denominator, and the common denominator is going to be 2x to the 3 halves. 2x to the 3 halves will go into 2x to the 3 halves 1 time. 1 times this is that. X to the 1/2 will go into 2x to the 3 halves 2x times. So 2x times 1 is 2x. Now we distribute the negative. Negative x plus 9 plus 2x over 2x to the 3 halves. And the 2x minus x leaves you with x plus 9 over 2x to the 3 halves. And if you'll notice, that is what we got using the quotient rule. Sorry. Okay. Same thing we got with the quotient rule. So now you can use the inverse rule of exponents and the power rule, or you can use the quotient rule. Or you can do x minus 9 times x to the negative 1/2 and distribute that. And I'm going to do it longhand for you. Sorry. I'm going to do it longhand for you so you can actually see what's happening. That'd be x to the 2/2 times x to the negative 1/2 minus 9 times x to the negative 1/2. Okay, so all I did was distribute that, and now I've got, instead of dealing with the product rule or the quotient rule, I just got to put these together and do the calculus. So 2 minus 1 is 1, so that's x to the 1/2 minus 9x to the negative 3/2. Oops, forgot my 1/2 out here. Be a negative 1/2 right there. Okay. Oops. No, it wouldn't be negative. It would be negative 3/2. Oh me. All right. Sorry about that. No, it'd be negative 1/2. I was looking at this. Negative 1/2. Let me just rewrite it. X to the 1/2 minus a negative 1/2 times 9 x to the negative 3/2. The reason I put a 3 there, I looked at this exponent instead of this one, thinking I was taking the derivative. So I'm sorry about that. Okay. Now x to the 1/2 minus, that's going to be a plus 9/2 x to the negative 3/2. Now of course this can come downstairs, and that's going to be x to the 1/2 over 1 plus 9 over 2x to the 3/2. And of course we got to get a common denominator, which would be 2x to the 3/2. And now 1 will go into 2x to the 3/2, 2x to the 3/2 times, so that'd be 2x to the 3/2 times x to the 1/2 plus 9. Okay. And I made a mistake with a sign somewhere because this is supposed to come out to be 2x. No, not supposed to be 2x squared, that's for sure. So I've made a mistake somewhere. Let me look over it. Bring the 2, bring that down. This is supposed to be 1x. Oh, I know where I've gone wrong. I forgot to take the derivative right here. That's what I did wrong. 1/2 x to the negative 1/2. Sorry about that. So that'd be 1/2 x to the negative 1/2, and that negative 1/2 will come down. Negative 1/2 x to the 1/2. There we go. And that 2, I need to bring 2x. That 2x will go here. Yep, that's what happened. So I need 2x. So 2x times 1/2 would be x. This is supposed to be a 2x. There we go. And 2x times 1/2 plus 2x times 1/2 is equal to x plus 9 over 2x to the 3/2. Sorry about that. Okay, so of course you see that you get the same answer 3 different ways. There's the same answer as that, which is the same answer as that right there. Okay, so that's how you do x minus 9 over the square root of x. Hope that helps.